So the motivation of this presentation is really a tribute to the late Ronald Coase. So Coase won the Nobel Prize in 1991, and he famously said, if you torture the data long enough, it will confess. Now, Coase actually was a theoretician, actually a very interesting one too. We overlapped at the University of Chicago when I was a student, but unfortunately, he was hiding out in the law school. But interestingly, as a theoretician, his papers had no equations, no mathematics in them whatsoever. That's not the case anymore. But nevertheless, let's start at this point. And what do I mean? So where I want to go, this is a wide-ranging talk that focuses not just on finance, but the way that we conduct science in general. So I will talk about strategic data selection. And this will focus, when I talk about finance, not just on academic finance, but practitioner finance. I'll talk about some of the classic problems in data analysis, including delegation, the garden of forking paths, concepts that you might or might not be familiar with. I'll focus on the multiplicity of methods that are available to us today. And it is striking, the number of methods, and it creates a dilemma because often people will pick the method of analysis that is most likely to support their result. I'll talk about manipulation. I'll talk about outright fraud. I'll talk about how to sample. And then at the end, I'll have some remarks on truth and the implications for investors. So let's start out with a white paper that crossed my desk. The topic, extremely interesting to me, by a well-respected asset manager. And the topic is the overlooked persistence of active outperformance. So this is the sort of thing that I do research in, and I'm quite interested in reading this paper. And it definitely caught my eye. So the basic idea of the paper is to look at performance through a different lens. And I'm all for doing that. And looking at the abstract, it says very clearly that they want to reframe the conversation. And I really like that. I really like reframing conversations. So what's the idea? There is a debate as to whether active managers outperform passive managers. So they're going to speak to this. And the idea, the innovation in their paper is to only include those managers in the top 3 quartiles of performance. Okay, let's think about that. So essentially, the bottom quartile of performers are deleted from the analysis. And when you do that, 84% of active managers have beaten the passive benchmark. And they've got very detailed analysis that is actually pretty intuitive. So if you look at all funds in blue versus the top 3 quartiles, in every single situation, the top 3 quartiles does better than all of the data. Okay, so this is one of the tables in the paper. And it's, if you really reflect on this, it's really, really hard to figure this out. Like how can you actually present this? It's so obvious if you censor the data that the censored data is going to look better. So indeed, the conclusion here is that 100% of active managers beat the S&P when you delete all of the managers that underperformed. So that, to me, is not that meaningful of a result, and hopefully you agree. So let me talk about another situation in the context of strategic data selection. So this is a very influential paper that was commissioned by Norges, and that currently has like assets under management of $1.1 trillion. So this was commissioned to look at the role, again, of active management. And again, I'm very interested in this topic given my current research. So this is in the report, the 2014 report. All this stuff's online, including the previous paper. So this is the key line for me, and that is abstracting from the financial crisis. We conclude that active management of both equity and fixed income has significantly contributed to the returns of the fund. So again, let's step back. So essentially what's happening here is the model works, so active outperforms passive if you exclude the single most important economic episode in the last 30 years, the global financial crisis. So again, this is what I call strategic selection of data. Okay, so I've, in my research, have been critical of the sort of methods that people use and have called out a number of researchers. But I've also called out myself. And let me tell you a story. And this is a story that happened early in my career. And Duke University had an early version of call ID. A call comes in about 9 p.m. and I know the number is a general number at Goldman Sachs. And I've got colleagues from the University of Chicago that went directly to Goldman, and we regularly talk. So I just figured this is a conversation, no big deal. And I pick up the phone and say hello, and maybe, I forget exactly what I said, but it wasn't a particularly complimentary thing to say. And then there was a long pause. And then the senior voice said, "Is this Campbell Harvey?" And then I knew, uh-oh, this is not one of my school buddies. This is somebody else. What's going on? And it turns out it was Fisher Black. So to get a phone call from Fisher Black as a junior person, that's just a huge deal. And it started out obviously very poorly. So then he says that he has a problem with a table that's published in the Journal of Financial Economics, one of my first publications, and it had just come out. So that actually got me stressed a little bit, to say the least. And the table was a table that basically was a market timing sort of model. So it was predicting 1 month ahead S&P 500 return. And many people have documented that there's a small amount of predictability in the S&P 500 return. And this is the table from that paper. And he tells me that this table is an example of data mining. And he said that the predictability was way too good. It must be overfit. So this is the particular model that he's looking at. It's got an R squared of 7.5%. And I basically said, no, this can't be overfit because I only ran one regression. So this wasn't a data mining expedition whatsoever. It was a single regression. I didn't search over all the variables, and I just reported what I got. So there was no attempt to maximize the fit. I was just following previous literature. So we had a long conversation. He stuck to his guns. I stuck to my guns. So it's really interesting to me that this call so many years ago, accusing me of data mining, it's so ironic given my current research program to basically call out the data miners. So recently I decided to do an out-of-sample test of the model that Fisher Black said was data mined. So the first thing you do is replication. And I had to collect the data. I didn't have the data that I used in this old publication. So everything was collected. And it turns out that the in sample replicated really well. So the R squared, 7.6%, and the original article was 7.5%. But what about the out of sample? So when that happens, it's a different story. The R squared goes to 0. It's not significant, which is consistent with data mining. Indeed, you can actually see in the data that some of the coefficients are very unstable. So it turns out Fisher-Black was correct, that this was an example of data mining. But how can it be data mining if I only ran one regression? And it turns out that the lesson here is that I might not have tortured the data, but if I relied upon others that tortured the data, it causes the same problem. And this is what I call a delegation. Okay, let's move on to the Garden of Forking Paths. So this is a very subtle concept, and it's sometimes described as the parallel universe problem. And this is much discussed by a statistician that I've got a huge amount of respect for, Andrew Gelman. So what is it? So think about the following situation. There's somebody that wants to develop a factor or a trading strategy, and they've got 20 variables that they want to look at. So think of it as a prediction model. And they start out, and variable 1 works. It's significant. And that researcher stops. And then maybe that model goes into production. And they can say, well, I just did one test. So there's no data mining whatsoever. I just did one thing. I didn't look at anything else. So we're good. So now I challenge you to think about the parallel universe, where everything's the same. The researcher is the same. The 20 variables are the same. But the order that the variables were tested is reversed. So variable 20 is tried, and it's not significant. Number 19, not significant. And ... all the way to the first variable, nothing significant except that first variable. And what happens to the researcher? The researcher says, well, I tried 20 things. One happened to be significant. Therefore, nothing is significant because I can easily get one thing out of 20 by chance. So the lesson here is that both situations need to be treated the same. So even though that first researcher didn't try all the 20 variables, you need to actually engineer your inference as if they actually did try all 20. Okay, so now let's go back to practitioner work. And this is a high-profile organization that I'll call GF. And this is a real example. And this stuff is on the internet. But to basically frame this, I want to go back to my Fisher-Black situation to kind of show you what the data actually looks like. So this is the S&P 500, and in the orange, in the blue, are my predictions. And if you recollect, over the first part of the sample, it was 7.5%. Over the last part, 1%. So overall, about 4%. So that's the R squared. And that's, you can see it visually, that the variance of the blue is really small compared to the variance of the orange. And that's why the R squared over the full sample is only 4%. So again, the predictions in blue, the historicals are in orange. So let me talk about this conversation. That I get a lot of phone calls, people wanting advice, and almost always free advice. And usually I don't give them the time of the day. But this I just couldn't resist because it reminded me so much of the Fisher-Black situation. So they were also predicting monthly stock returns. The difference is that they were going to look at not just the US, but 59 different markets. So there were some markets that were excluded, and I didn't have any problem with that whatsoever. These markets have short sample and are illiquid, but the big ones were all there. So it sounds very interesting. And they described it, and this is again on the internet, product of over 2 years of intensive data collection. And that they had tested roughly 200 monthly variables, and the sample from the 1990s. And when you look at all of the monthly data, the 59 markets altogether, plus the 200 variables, we're talking about 3 million data points. And then we learned that the analysis uses multi-stage method and the most advanced machine learning algorithms, plural. So, of course, that's my first question. What algorithm did you use for this analysis? And the person I was talking to wasn't forthcoming. And I think that's really important because within the machine learning space, there are lots and lots of methods. And it is so tempting to choose the one that actually works. So how accurate is the model? So they claimed that the accuracy is impressive. And for the big 25 economies, R-squared of 0.96, and for all economies, 0.98. I'm thinking, okay, they're probably thinking percentage, because remember, over the latter part of my sample, I got an R-square of 1, which is really close to 0.98%. No, it's not 0.98%, it's 98%. So let's take a look at that graph that I showed you for my model. So the orange are the historical realized returns. The blue are the one step ahead predictions from this GF model. And that's what a 98% R-squared looks like. The variance is about equal. And the predictability is remarkable. Especially, look at that October 2008. That was the worst month of the global financial crisis. There was a minus 35% return. And the predicted value at the end of September from this model was minus 35%. Okay, so what's going on here? This model is massively overfit. And you can actually see, remember my model with the 4% R-squared, the GF model, 98% R-squared. Okay, so it's a huge difference. And it is implausible to even think, if you got 98% R-squared, why would you publish it? Why would you put it on the internet? So again, it doesn't really stop here. They claim the out of sample works also, or they hold out some data. On further questioning, I found out that the data really wasn't held out. It was all within the program. So the out of sample is questionable. So it doesn't really stop here. They claim they want to improve. 98% is not good enough. So they want to look at additional variables. They already have 200 variables for each country. And notice they don't even have 200 observations per country. They want to develop a nowcast, and many other improvements are in store. So you can't really make this up. It's remarkable, and this is what we see today. Okay, let's go back to academia. This is a paper in financial accounting. It was on the AAA program. And I've got two examples here. Well, one finance, accounting, economics example, another one a little later. I call this multiplicity of methods. So this research argues that there is an upside to unionization within a firm. So after unionization, the risk that the stock price tanks or crashes decreases. The economic mechanism is not clear, but as an empirical paper, let's look at the data. And they're going to use regression discontinuity design. So this is what it looks like. And notice that the straight line in the middle is the 50% mark. So if the vote to unionize is less than 50%, then the union vote fails. And then you can see to the right, the union vote passes. And they argue that when it passes, the crash risk actually decreases. And you can see that with the gap at the 50% line of those two curves. But look at that data. Okay, so what's going on here? So in the paper, they admit, we initially estimate polynomials of order 1, 2, 3, and 4. We find that the results using the polynomial of order 2 are the strongest. This is overfitting. So just eyeball the data. You fit a polynomial of order 1, which is just a linear, like a straight line. There's nothing there. It's flat. But if you try 2, you get that gap. So again, this is just an example of overfitting the data. It's also interesting, I looked up the lead author, and the lead author on his CV has got 15 papers trying to explain crash risk with different variables. So the idea here is that if you try enough variables, then you're going to get a significant relation. Okay, so many of you know I'm Canadian, and I couldn't help but be interested in a story that came out this year, a publication in a very high-profile medical journal, the British Medical Journal. So this study has to do with the outcome of the US election affecting the sex ratio, so male to female births, in the province of Ontario. So again, this is a top journal. It's got a very high impact factor, very well respected. And essentially, what the researchers do is not just look at the overall population, but they divide it into the population that is liberal leaning versus conservative leaning, and argued that they should see a decrease in this ratio only for the liberals because they were very upset that Trump won in 2016. So that's the hypothesis. And the results are striking. The p-value is 0.006 for this analysis. So again, let's take a look. You don't need to be a medical researcher to figure this stuff out. And indeed, it's interesting. I challenge all of you, take a look at the medical literature. It's pretty easy to understand this stuff. So here is the time series of the overall sex ratio. And the overall average is 1.06. So that's male to female. It's very stable. And this is the monthly data for the province of Ontario. And that's my home province. And you can see that the election is marked there in November. And they hypothesized that this change in the sex ratio actually happens 5 months later. So looking at the data, I don't see anything in particular, but again, they're going to slice and dice by political affiliation. So let's take a look. On the top right, we've got the liberal areas. And in the bottom right, we've got the conservatives. And again, looking at these data, it's not clear, eyeballing the data, that there's anything there. In addition, almost all of these dots fall within plus or minus 2 standard errors. There's like one observation that's just a little bit outside of that. But it really depends on the model you fit. And the model they fit is the following. So you estimate before, and you estimate for the 5 months after, and you can see that at the dotted line, which is 5 months out, that there is a significant difference. So this is where the p-value comes from, 0.06, 0.006. And this is the sort of stuff that gets published in a very top journal. Not in our field, but nevertheless, we've seen many examples like this in our field. Okay, so let's kind of go back to out of sample. This is the example I showed you from the GF model where I questioned whether it was really out of sample. And look, a good lesson here is there's really no out of sample other than kind of live trading. So for example, if I fit a model to 2005 and then hold out the next 15 years, I've already lived through the global financial crisis. I know what happened in the global financial crisis, and that's going to change or impact the choices that I actually make in the modeling. So this is a paper that won first prize, the best paper in the Journal of Financial Economics in Investment. And this was just recently announced. And take a look at this table. So it says out of sample factor performance. So not in sample, out of sample performance. And look at the model with 6 factors. And look at the out of sample Sharpe ratio, 4.05. Okay, so just to be clear here, this roughly means that for the same volatility as the stock market, this investment would earn about 60% per year. Okay, so this just can't be. And it's remarkable that this is even referred to as out of sample. This is just another example of overfitting. There's also fraud. And I think fraud is not as common in financial economics as it is in other fields. In medicine, it's really all over the place. And this is an example of basically 121 Chinese papers being red flagged. The images that they were using were basically all the same image, a stock image. And essentially, these researchers contract out to a paper mill, and the third party basically writes the papers, submits them to journals, and tries to get publications for the authors. And I guess presumably these authors get promoted or move to better jobs. So this is the stock image. And you can see that different researchers used it in different ways. So the number 2 shows a subset of this image that was actually used in a pretty good journal. And again, there's many of these different pieces of the image that are used for publication by other people. So these are just completely fake publications. And it's a really striking example that many areas of science are really fundamentally broken. Okay, so I'm getting close to the end of my presentation, and I want to kind of reflect on the sort of lessons here. So let me talk about Rudy Giuliani. So he made these statements that seemed ludicrous in August of 2018. So one of them was, the truth isn't truth. The other one was, the truth is relative. The third one is that investigators may have different versions of the truth. Okay, so, and we know who Giuliani is, President Trump's attorney, and this is this is a sort of picture that you might see in the more liberal-leaning media, and this is the sort of picture you might see in the more conservative-leaning media. So I actually think that what he says is pretty accurate. So not that I usually disagree or agree. I don't really have a strong opinion here, but he was raked over the coals for this, but probably he shouldn't have been. Because it is a fact that even philosophers can't agree on what the truth is. And I've just subsetted a small group of the different theories of the truth. Okay, so we need to be really very careful when we say this is the truth. Okay, a lot of it just depends upon the construct. And that's important to realize. Okay, so my last example is very appropriate for those interested in behavioral economics and behavioral finance. So in the past, I have been somewhat critical. I've published in behavioral finance and economics, but we need to be really careful of all of these biases. So there are so many biases that it reminds me of the factor zoo, that if you try enough factors, you're going to find something that actually works. So we need to be really careful here. And this is a paper that got quite a bit of attention. So basically, they were investigating fake news. So the idea is, can we investigate why fake news goes viral? And the answer in the paper was striking. It has to do with limited attention, which is something in behavioral economics that is a big deal. So obviously, given that fake news is in the news all the time and politicians use the word all the time, it's no surprise that this paper goes viral into the 99th percentile of media coverage. It is picked up like all over the place. And in places like Scientific American, which is not a tabloid publication, but a respected publication that tries to distill in a very careful way the latest scientific advances. So this appears in Scientific American and literally hundreds of other outputs until the paper's retracted. So it's kind of ironic that the paper that is trying to explain fake news is fake. So let me conclude. So we've all heard, let the data speak. Indeed, when I was a student at the University of Chicago, it would be often the case that we would hear the professor say, when we're studying our paper, well, let's go to the data. Let's go to the tables. Okay? And you'd look at the tables individually. And basically, your read of the table would kind of, for an empirical paper, tell you what's going on without actually looking in detail at the text. So you kind of avoid the author's bias by looking at the tables directly. But the data do not speak. The tables do not speak. Those tables are designed by the researcher. They're reporting what they want to report. So it turns out, and hopefully this is obvious by this point, that it's the interpreter of the data that speaks, not the data itself. And the interpreter often has an agenda. And there is a set of tools that researcher can use to basically support the narrative. And indeed, I've talked about this before, that in academic research, the best chance of getting a publication in a top journal is to have a significant result. The journals don't want to publish papers with non-results. Those types of papers don't get citations. It doesn't help the journal in terms of impact factors. So that creates an incentive to mine the data to try to get that significant result. So we need to be careful. And this is especially the case in finance. We're now in this era of big data. The data we have today, we couldn't have dreamed of 10 years ago. The computing power, the number of predictors, the methods that are available to us, the computing resources. And you all need to put that in the context of the incentives to strategically manipulate the data and uncover what we might call a convenient truth. Convenient in that it supports the narrative of the research. This is important for academia. It's important for the practice of management too. It's often the case that some academic paper shows a result, and practitioners are eager to replicate that result and wrap an ETF around it and then sell the product saying, well, this is based upon peer-reviewed scientific research. Well, let's be careful there. We've seen plenty of examples of peer-reviewed research that was overfed. And when something's overfed, you know what happens. It looks great in sample, and then it fails badly in the other sample. So I think, again, this is a situation that is more important today than it was in the past. It was in the past just more difficult to do data mining. Today, it is incredibly easy to mine the data. So it's much more dangerous. So in the end here, I would like to put a plug into my latest paper called False and Misdiscoveries in Financial Economics. It was published in the October 2020 Journal of Finance, and it directly addresses these problems. And it really focuses on what is kind of a minimum hurdle for establishing something that is significant. I also explore the relative costs of type 2 and type 1 errors. And this is something that we don't really think about that much in finance. So a type 1 error is to hire a manager that you thought was skillful, and a type 2 error is to basically reject a skilled manager by mistake. So that's available. And indeed, reach out to me. I'm available on SSRN and LinkedIn.